Hi everyone. You present me too well, and now I'm more emotional. I have to do really well because you speak really hard with me. Thank you for the warm welcome to LibanPost and my compliments for the quick organization of this great conference. Thank you. So as Bernard said, I work for a research institute in Palo Alto. It's called the Institute for the Future, and guess what we do? We research on what's going to happen in the next 10 to 20 years, and we try and build scenarios. You want? Sure, why not? Thank you, that's easy. So I feel like I'm on TV. Good, excellent. So yes, we create scenarios about the future. So we don't, just be very careful when people tell you they can predict the future, especially if they come from California. Nobody can predict the future, but we can create scenarios and try and understand what forces are going to reshape our lives in the near future. So today I'm going to talk obviously about the future of technology, innovation in general, some of the things that are really going to disrupt our daily lives and work in the next 10 years. So I'll skip this part, we've already done enough presentation. Okay, so I'm going to start with this slide. This is the 1980s. Maybe some of you remember what this is. This is actually, you could call it a website from back in the 80s. It was called, at the time, used to be called Bulletin Board System, or BBS. Okay, so it looks a bit like a menu. What I wanted to show you here is some of the items that were already present back there. You have a file transfer, you have a chat, okay, and then again we have got messages, the ability to send message, to do posts, okay. And we also had the read, send email, the first forms of email that we see on the internet, okay? So these were we have a user list, again, here below, okay? So very primitive forms of online communities. And funny enough, if we go ahead in time and we look at Facebook today, we really find the same things. We have user lists, we have posts, we have messaging, and we essentially use websites and online communities to do the same things, which is connect between us and exchange content, data, and more and more. This used to be the Apple website. I look, they were advertising in 1997 the use of CD-ROMs, big thing, the CD-ROM. Remember CDs? You know what we're doing with CDs today? This is what we're doing with CDs today. We're making art out of it. So, huge transformations are happening, okay? 2016, this should be today, if I'm not mistaken. So we are today in what we call the age of abundant data. It's big data age, okay? So big data, why? Because we're really collecting a lot of data from an enormous amount of resources we have. So the age of big data is really made of mobile phones, everybody has one. We have wearable devices, but we are putting sensors everywhere, and we have social networks, as we talked about before. We have intelligent interfaces coming along. How did we get to this point? What brought us to this age of big data? Let's go back again in time, and let's go back to the 60s. In the 60s, at the Institute for the Future, one of our founders, his name was Paul Barron, with a bunch of crazy engineers, theorized that what you see in this drawing would eventually happen. So that we would go from centralized systems to decentralized systems to distributed systems. And what does this exactly mean? I'm going to try and explain this to you. This is 1953. This is the poster of a show, a TV show called I Love Lucy. And why am I telling you about this I Love Lucy? Because for the first time what they did is they decided the actress Lucille Bale was pregnant at a certain time and was about to give birth to her child in reality. So what they did is they made it happen so that in the TV series the actress was also giving birth to a child. And they advertised this, and even the Newsweek talked about it. So the person in reality, the real woman giving birth, and the actress in the TV show was also giving birth to the child. So this, as advertised, generated a 72% of the American audience sticking in front of the TV to watch this event. This was, why am I telling you this? Because this was one of the first cases of mass experiences, okay? In fact, we call them mass media. This was TV as much as the telephone is technologies that are originated from centralized systems. In both the telephone and television, you had a central emitter of a signal that would send you to a signal to a receiver, okay? So centralized systems. This, on the other hand, is not an image coming out of centralized systems. This is an image of the Arabic Spring. And this is coming out from a different type of system. It's coming out of social systems, of decentralized systems. Why? Because the Arabic Spring really originated from a series of news and posts and content that was published in social networks before it actually went to the squares. So, centralized to decentralized, this decentralized architecture generated social experiences. And now we are in the time of distributed architecture, system architectures, and we are creating what we call ambient experiences. Ambient experiences will be with us for the next more or less 10 years. So this is the internet that is about to come. And we'll see now why we call them ambient experiences. We have 5 new capacities of technology today. And it's very important to understand this, so you understand what you can do with technology, how far technology can take you, because technology is about to become an even stronger divide. You know, you either have access to new technologies, or unfortunately, who does not have access to new technologies will be left behind very fast, because things are moving really, really fast. So 5 new capacities. Today's technologies and future technologies are embedded. What does it mean embedded? They are inside of everything. You know, you've heard terms like, you know, the Internet of Things and other things like this, where we are putting processing power into everything. So technology is becoming from extrinsic to intrinsic. You know, we used to have technology in front of us, like we have our computer, there is a laptop, the laptop is there. But today we have wearable technology, we can put it on us. Okay, so, and we can even put technology inside of things. We'll see this later, the Internet of Things. What is driving some of the changes that are happening are obviously, you know, the development in the production of technology and hardware and software. So look at what's happening to the transistor size and what has happened in the last years. So the transistors are becoming smaller and smaller and smaller. This allows us to put sensors in every object, and it will be even more in the future. Technology is also illuminated, so it's going from being heuristic, essentially based on, we take actions based on data collected before, to being optimal. So as we collect data, technology is adapting and changing at the same time. It's not a separated process anymore. Why is this happening? We can see this. As much as we are feeding data and elaborating data to machines, machines are becoming smarter, and the error rate of machine learning is dropping down. We're kind of like training our machines. Technology is also becoming anticipatory. We also call it predictive, okay? From reactive to proactive. And why? This is the AI patents count. As you can see, as the transistor cost has been dropping down, along with the transistor size we've seen before, artificial intelligence is growing. There are more and more companies that are registering patents for artificial intelligence. And artificial intelligence is a term that we're using more and more every day. Multisensory. Technology is becoming multisensory. Why? Because it's becoming from visual, something that we watch on the screen, to embodied, to more and more physical. We're beginning to talk about augmented reality, virtual reality. And look at the patents here. We have VR, we have haptic devices, devices that track movement and are able to transfer movements. We have voice recognitions. These are all things that happen around us. Our interfaces are becoming more and more interactive. At last, technology is becoming programmable. We do not have only one device as we used to have. We started having one computer, most of us, maybe two, one at home, one in the office. We now have a multitude of different devices. We have mobile phone, we have wearable bracelets, we have trackers, and we can now connect these devices to obtain a new range of services. You can see this by the number of internet-connected devices is driving also the rise of virtual assistants. Why virtual assistants? Because the more devices, applications, and things and technology around us we have, the more it will be difficult to manage it and make sense of it. So we're going to need, at a certain point, virtual assistants to manage all this data, and we'll see this later on as well. So we said we are in the age of big data. We're collecting an enormous amount of data. And this data is really giving us a vision of the world at a new, very deep level of detail. And this is very important because we're seeing things that we could not see before, because we're gathering data and crossing data from 4 distinct dimensions. We have the planetary dimension, we get data from space. We have a satellite network which is fully functional and constantly feeds us with data. We even have space junk today, so there is a lot of stuff in space that is data. Then we get data from smart cities, from all the infrastructures we have in cities, public transportation, smart buildings. There is IT everywhere today. But we also get data from social networks. Think how much information we're constantly feeding to our social networks. We're telling people everything about us, about what we do, who we see, what we eat. We post pictures, we write about our experiences. And again, we're getting data from the 4th dimension of biological systems. At molecular level, we're even collecting data. We have nanotechnologies. Okay? We can swallow today a pill that collects data from our stomach, from within our body. And this really is making us understand how everything really works. And this is making us understand our complete ecosystem. For the first time, we've not been able to see this far before. Our ecosystem is becoming a world in which people and things are connected. We call it the Internet of Things. This is the new era of the Internet we are entering right now. We're at the very beginning of the Internet of Things. We're just going through the age of big data into the Internet of Things. We are placing now the first sensors everywhere. You can see we already have cameras everywhere. We are starting to have smart objects who are feeding us new data. And what is really happening in the Internet of Things is that we are redesigning our systems in the image of the Internet. First we designed the Internet to assist our everyday lives, but now it's the Internet that is actually reshaping our everyday lives. Now the Internet of Things is something you obviously have heard about a lot, and I'm just going to quickly tell you about 2 fundamental mechanisms that you should really understand well to understand how the Internet of Things works. Without getting too technical, but we have 2 fundamental things. APIs, some of you may already know about APIs, but APIs are something very important. Why a kitchen sink? Yes, because this is a very basic example of an API. Why is this an API? Because a kitchen sink is really an interface that we use very easily. We know it's very easy to use. You just turn a knob, you get hot, cold water. But really behind this very simple interface, you have this. This is a very complex piping system. Do we need to know this is there to get water? No, we don't. We just need to open the kitchen, the sink tap. We don't even know that this exists behind this. It's not important to us. So the API is an interface to very complex systems, a very simple interface. So simple that anyone can use it to tap into your resources. And resources are, of course, hidden in the complex network of pipes or in the complex network of connected devices such as the internet. So why am I talking to you about APIs? Because it is through APIs that today we use some of the most common services, like book a room, a hotel room through Booking, or book a room through Airbnb. All these systems work through APIs, connecting different data and data sources, exchanging information in seamless ways. Whenever we buy a product on Amazon, we go through APIs to get it shipped, to get it to us, okay? Whenever we watch a video on YouTube, whenever we watch it on a different device, an API allows us to connect in different ways to content. Whenever we call a cab to go to the airport, these services are all enabled by the existence of connectors that are easy interfaces that are called APIs. The other mechanism is triggers. Triggers is even more simple. They work based on a simple recipe, if this then that. What does it mean? If this happens, then something else happens. So if there is an event, this event can trigger an action. And devices through these recipes can be connected to do things together. Remember before we said we're going from solo to orchestrated? So this means that we're not just communicating and using one device, this means that we're using a combination of devices to access new forms of services. An example is I could be driving my car, and because I have my smartphone, and my smartphone knows where I am at all times, it's got GPS location, and it knows how far I am from home. Not how far I am from home just by the position, but also how long it's going to take me to get home, because I also have the information on traffic. So, with a simple recipe, I can tell my other smart appliances at home to switch on or switch off. I can say, okay, when I'm 10 minutes away from home, you can switch on to turn up the heating, or switch on the lights, or maybe start cooking something with a smart oven. Okay, so triggers. If you don't understand these two very simple mechanisms and how they work, you're going to be out of everything. It's very, very important to understand this, because the whole of Internet of Things is based on these two very simple mechanisms. People and things. So what's really going on again? Today, thanks to these mechanisms and new abilities of technologies, we have things like the biggest taxi company in the world that has no cars. We have the most popular media owner, Facebook, we all know it. They don't create any content. We people do it. It's our mass workforce that's creating the content here. Airbnb is the largest accommodation provider. I mean, do you remember do you realize how fast Airbnb became to be the leading accommodation provider in the world? It just took a few years. And even then, they own no real estate. It's just a connection in between things and people. Alibaba is the second most valuable retailer in the world. The first one is Amazon. Why am I saying Alibaba, not Amazon? Because Alibaba has no inventory. Amazon does have inventory, so I'm citing Alibaba for this reason. And this is highlighting a very important concept. And we're going from ownership to access. In the future, it will not be so important to own something, but it will be more important to have access to a service based on something. So in the future, we will buy more than things to own, we will buy access to things. Subscriptions, monthly services. And this world will be a world where human and machine will highly live in symbiosis. We're getting closer and closer to our machines. Okay? Some years ago, machines were far away from us, so I was telling about this last night. Today, technologies is on us. The next wave of technologies will be embedded inside of us. Okay? So not only wearable, but implantable technologies, nanotechnologies that we can put in our body. And this is not science fiction, this is really happening today. So just to explain to you a little bit better how we come to define these scenarios for the future of the Institute. Before I was telling you what we do, that we create scenarios. Just very quickly, one technique that we use is we take existing technologies and we combine them in different ways to verify and see what enablers and what's going to happen combining these new technologies together. So I'll give you 5 examples of this. So I'm not going to go through this, we don't have time to go through each one of these technologies, but if we combine these 7 technologies together that are all available today, we get something that we call continuous capture and sense making. Today, we have the ability to track everything, to record everything that happens, every minute, every second. From body data, we track our heartbeat. I mean, there's even people tracking the growth of their nails. So we can track everything, okay? And we can make sense of this data because there is artificial intelligence that is constantly churning a huge amount of data to make sense out of it and understand where we're going. If we put together these technologies, on the other hand, we get something else. We get the ability to simulate complex decisions. I told you how our ecosystem is becoming more and more complex every day thanks to this huge amount of data and the enormous amount of devices we're putting everywhere. So, are we really able to make sense out of all these complex systems? Maybe not. Maybe we need, the ability to simulate things and to understand what's going to happen before we actually take action. So simulation is becoming really, really important. You don't send a rocket into space without simulating 1,000 times before what's going to happen, right? If we put together these technologies, on the other hand, we get on-demand intelligence. What does on-demand intelligence mean? It means that anytime I need, I can call upon processing power to help me out, to have artificial intelligence. Like for example, today, to give out this presentation, because I'm showing some video content afterwards, I asked the organization to provide a fast and reliable internet connection. And so we have today, for this conference, a faster, more reliable connection than the normal connection there is in the hotel. This is on-demand intelligence. We call this, a little bit more processing power and bandwidth just for the moment of today, because we need it now. And it's there. Why is it there? Because we're connected, and we can call processing power as we need it, when we need it. One before last, if we combine those technologies, we get another example, which is called evolvable hardware. Evolvable hardware is something I like very much because I always thought that we waste a lot of resources in everything we buy. We use them, then throw away. If you remember, back in the old days, you bought a television, for example, and then, hey, we have new TVs with flat screens. You just throw away the old one and buy a new one. So you completely replaced products. What's going to happen in the near future is that you're going to buy a product and you're not going to replace it once new features come out. You're just going to add features to it. You're going to buy additional modules. This is coming from computers. I mean, if you remember back in the days, you bought a computer, then it became slow, then you add memory to it. You change the processor, okay? So the hardware evolves as we need it to evolve. If we put together these technologies, we get one last thing, which is encoded judgment. Encoded judgment means the capacity of technology to make judgments in any given situation in place of us. So we can be moved from making a decision. And this can be not very nice if you think about it, but very dangerous. But machines are becoming able to take decisions. A smart traffic light is a very simple example of that. You can have a traffic light that turns red or green depending on what it senses around the area. How many cars are coming from one side or the other. It makes decisions. So, we've seen how we're going from mass to social to ambient experiences. Now, let's see some signals and some examples of these ambient experiences. I know sometimes we find we're using some weird terminologies at the Institute that we're creating, especially to look like we're working on something really serious, but at the end of the day, it's really simple to understand. So don't be afraid of these terminologies. Machine orchestrated entertainment is something that is already happening. Machines are working for us to give us the best entertainment possible. This is a video game that allows you to put your face on the player, so you can see yourself playing in the game. But there is also technology, Juke Deck, it's an app that allows you to compose music and make music that sounds really nice, even if you don't know anything about music. You know, you had to study before, you had to know music, you have to be able to put it together, notes and everything. We have expanded sensorium. Expanded sensorium is the ability to sense more, and the expansion of senses. This is a very silly experiment, but you know that the outcome of this is not so silly. This is actually a robotized chicken, and the idea is that the chicken, the fake chicken, will move because a real chicken somewhere else is being tracked with sensors. So as the real chicken moves around, this fake chicken moves around too and does the same things. Now this sounds very funny, but it's a very serious experiment. This means transferring from one place to another haptics, the capacity to move. Here, expanded sensorium, being able to extend our senses in places where we could not go before. Now, this is it seems a very known example of an underwater submarine, but this thing is actually as big as a laptop. Actually, it's smaller than a laptop. So this is like a personal exploration submarine that goes very deep into the sea and sends you video feed. But it's not something that you buy for millions or that only scientific institutes have nowadays. You can buy it. You can buy it in a shop. It's accessible to everyone, just as much as drones are. Then you cannot fly them, but you can buy them. So one of the problems, obviously, regulations in all these things and policy making. Searchable matter is another nice terminology that we invented there. It means the ability of machines to understand what's there in an image. So Clarify is an API that allows you to understand what's in an image or a video. So the machine knows that this red thing is a tomato. And you know how the machine learned to recognize objects? Through Google and to all the other search engines. Every time we search tomato and we get an image of a tomato and we click on it, we're teaching the machine that this is a tomato. Okay? Either machine vision is also doing some very important thing. It's helping people with limited senses or problems or disabilities or blind people to recognize what's around them. If you can't see, there will be a machine that will help you to see what's around you. That is, by the way, an experiment done by Microsoft. Machine-created memories. This is another phenomenon that is happening nowadays. This simple bracelets constantly records in loops of 60 seconds all the sound that in a room. So you can actually go back of 60 seconds and keep a recorded file of what is happening in the room. So you can keep track of the past in a sense. You can rewind 60 seconds ago and reuse the data. If you're using Google, if you're using Google Photos on an Android system, for example, you notice that if you go on a trip and you, of course, enable this functionality, every picture you take is stored into a file, is saved online, and then when you go back home, Google will send you a message. It goes, hey, check out your new photo album of your trip to South America. Okay? This is machine orchestrated memories. We don't tell the computer to do that. It's the computer that does it by itself. Digital speciation is the multiplication of digital technologies everywhere. Where this device is a camera. You can see it's mounted on a pair of glasses, but this camera is also connected to a speaker that goes into your ear. And depending on what the camera sees around you, the speaker will give you messages, contextual messages. Okay? So for example, be careful, this, like if you're blind, there could be an eye instead of your eyes telling you what's happening and sending you a message. Imagine you're blind and the car is coming towards you. This will see the car and will tell you, watch out, there is a car coming towards you. Agents over apps. Do you know how many apps have been produced so far? I don't. But I know that an app lasts in an app store, the average lifespan of an app is 30 days. I mean, we use apps for longer than that, but there are only a few apps. I mean, think about how many apps are out there and how many we actually use. There are only a few. And one of the reasons why this is happening is because we cannot manage more than a certain amount of information. So this is driving us to go towards digital agents, virtual assistants. I'm sure you noticed today you can get a virtual assistant on your phone. You have Siri, you have Microsoft Windows with Cortana, you have many other digital assistants coming out. You have Assistant AI, which is a new company in Silicon Valley that specifically builds virtual assistants. And this is happening because we're going from an ecosystem of application to an ecosystem of virtual assistants, where we just simply tell our assistant, I need to do this, and the virtual assistant will run the algorithms and the software needed to have you get to the service. You tell your virtual assistant, show me the route to go to the airport, and immediately you will get a Google Maps route to the airport. Body right management, we're getting into the tricky stuff here. Because we're constantly collecting data, and because we're collecting very sensible data about ourselves, this is Fitbit is an example. It's going to be very tricky to regulate how we manage this data. For example, we have something that we call, you have automatic updates. We all use them. Our software automatically updates. So there is a new release, the computer doesn't tell you anything, you get an update. This has been happening also to Fitbit. And recently, Fitbit, actually some months ago, Fitbit has added the capacity to monitor your sleep. Now, this is very sensible data. Because, it may not seem evident, but imagine, I've not slept well tonight, and I'm driving, and, nothing too bad happens. Maybe I have a small car accident, nothing major, nobody hurt. You don't want to think about bad things in the future, but, something like this. If somebody has the data of my sleep, we could possibly argue that the night before you didn't have enough sleep, so you were not awake enough when you were driving. So your insurance company may have a problem in paying you. Okay, so it's very, very delicate what we're going to do with this, biological data. And also, we're gaining the ability to influence our own brain's capability. This is another experiment where, brain waves have been, through stimuli, through electrodes, have been modified to increase the efficiency of the pilot. So this means we can augment individual capacities to do more and better. And this is nice, apparently, but what happens if you don't get that capacity? There's going to be a whole range of superhumans with superpowers, and what about the rest? Very serious things. Biomedia on the same wavelength. All this data collected about our sleep, about our heartbeat rate, blood pressure and so on, is actually, if you allow it to do, it's actually collected and stored in a data bank of all the data coming from everyone in the world. And it's very sensible information. This is another interesting experiment. Now we're going to more lighter stuff. Zedstead is a rock band that did a concert where they gave everyone a small device to track the heartbeat. And they were, according to, you see the wavelength there, according to, they could see how fast the collective heartbeats of the people were going. So, you know, how emotional were people in respect to their music, and they could change the song, you know, make a sadder or happier song depending on this data that was collected in real time. Remember how we said before, technology gathers data and adapts in real time now, not after? This is another example. Shareable presence. Shareable presence is virtual reality, augmented reality is the ability to share our presence in multiple places at the same time. These are just some examples. I mean, these are images I'm sure all of you have seen. Some of us used to see those only in Star Trek. Now they're reality. You can have holograms projected. You know, this guy is wearing a device called HoloLens by Microsoft that allows you to see non-existing objects in front of you and in forms of holograms. This is there. Animation and reanimation is, again, there are two companies already, for example, Sephora and Taco Bell, that are already developing their own digital assistant, their own bots, to interact with users on social networks. So in the near future, you may find yourself interacting maybe on a social network or on a website with somebody that seems very real and it seems like it's a person answering to your needs, but it's not. It's actually a bot. It's a branded bot. Every brand will have an artificial intelligence entity representing them, interacting with the customers and with anyone, giving them information, help. But we're also going from screens to physical representations. As we said before, we have holograms today. We have virtual reality, we have augmented reality. We don't just see things and content on a screen, we see them around us. And this is all part of this ambient experience that technology is creating around us. So, going towards the conclusion, let me give you some hints of what's coming in the near future. I hope you remember this image, future. Let's not be too shocked, you know. I'm always afraid because people at a certain point look at me a bit, you know, spaced out, but yes, this is really happening. And as we move along in the presentation, I'm showing you things that will happen further down time, but this is something that will fly in about 2 years. This is a Swiss experiment. This is a stratosphere drone. We are conquering the stratosphere, this piece of atmosphere that actually it's below the atmosphere. We've built a satellite network, as I was telling you before, but satellites are extremely expensive to manage. Just imagine, to put the satellite in space, you have to use a rocket. Now we have reusable rockets, okay? So rockets are becoming cheaper and cheaper, but still, it's a lot of money to put up a rocket. Stratosphere drones are drones that can be deployed the stratosphere. In the stratosphere, the air is very thin, and they can fly perpetual flights with solar panel, so they can stay on air around in the stratosphere forever. They can keep going around. This will allow us to very cheaply substitute satellites to bring data everywhere, to bring internet connection in the middle of a desert, okay, or to get atmospheric data and you know, we just cover the whole planet with a network, with a new network, a cheaper, more efficient network of similar satellites. Now this is a video of, wait, let me turn the volume down, because otherwise I'll be really shocked. This video is actually a video made by an artist. His name is Keiichi Matsuda. It's a Japanese artist living in London who made this highly technological, extreme projections of our future. So this is how your life could be in the future. It's a bit extreme, obviously. It's not going to be like this, but to give you an example.
Seguro que no hay más trabajo disponible. Estudio para ser profesora y estoy haciendo mercados.
Y además puedes privarte conocimientos de especialización. Eres una noche afortunada. Tienes que contar
Virtual assistants, augmented reality, big data. This person is actually on a tram ride, losing the sense of who they are.
No es lo que quiero decir.
There's gamification everywhere, there's points. We're up to the point where our own digital identity can be reset and manipulated. Okay? This is a piece of art. It's not something, you know, but it's just to get you in the mindset of things that are about to come. Okay? I'll move forward. We don't have enough time to see the whole thing, but you can find those videos on YouTube if you look for Keiichi Matsuda. Robotics, highly important, also for the postal system in particular. My Robots is the first example of a social network for robots. Is a new social network populated by robots, not people. Robots that exchange data. We exchange data ourselves, we post pictures, we write tweets, we post everything on Facebook. Robots can do the same in this social network for robots. And what they exchange is useful data. So for example, the most commonly diffused robots outside of industries today are vacuum cleaners, low automatic artificial intelligence lawnmowers that cut our grass. And they can be put online in this social network and exchange data in between themselves to enhance procedures, to cut better the grass or to be quicker, what routes you make to be quicker in cleaning or cutting the grass. And this is my friend David, who is one of the fathers of robotics. And I'm going to show you here one of his latest creations. There you go. Robots are not in factories, just in factories anymore. Robots are coming to life in our everyday life. This is about to come to us, and this is a personal assistant. We will see androids like this walking around us, doing things for us, giving us services. It could be a butler, it could be a waiter, it could be a cleaner. I like to see this a little bit because it's quite impressive in my opinion. And I think that, and David is you know, like crazy. He's trying to not just create the rational intelligence behind this. As you can see, he's playing with he's recreating the emotions, the facial expressions, giving expressions to machines. This guy used to be in the US, then a Chinese venture capital firm went to him and actually bought the whole thing and moved him and his family to live in Shenzhen, in Hong Kong, and actually he lives in Hong Kong. His old company, Hanson Robotics, has been transferred to China. Huge investments have been made in this sector. The blockchain is very complex. I'm not going to even try to explain it today. It's very long, but it's a technology that is born out of distributed systems. It's the ability of giving validation not to a central entity, but to a distributed system of validations. Bitcoin is a virtual currency based on the blockchain, which is the main example today of blockchain. But we also have something called Ethereum, which is a platform that allows us to create DACs, DAOs, and DCOs. What are those? They are digital autonomous entities that work online. A digital autonomous corporation, a DAC, is actually a company, a digital entity that acts as a company and only exists over the internet. So for example, let me give you an example of this. Imagine if you have two companies who have a contract in between them. What's the best way to monitor if this contract is actually fulfilled? Is to create a third entity. Now normally we would use an authority. An authority is made of people. People can make failures, people can be corrupted. But not a digital environment, not the blockchain. You cannot corrupt the blockchain. So these entities can act as a new form of digital companies, performing a number of services that are absolutely independent from human action. There is a venture capital firm already in Silicon Valley, it's called First Capital, and in its board, the board of directors has one digital member that has got voting right. An algorithm with voting right. Understand how, these are big, big changes. This would have never happened before. This is a smart kitchen, an image again coming from Keiichi Matsuda. We will see smart appliances that will reorder consumables. You know, a dishwasher that will reorder soap when the soap is finished. Totally autonomous. There is no more human interaction in these things. Or we'll have things like Crespi. Crespi is a thing to understand the biological composition, the molecular state of any vegetable, fruit, any substance. So we know exactly what's in that tomato that we're eating. And if it's good, bad, or even like something more light, what recipes I can cook with it. Now this is going to get a bit weird for most of you. This is an image that some of you should know from the Matrix. So if you take the red pill, we're going to take a little bit to the internet of the very future, distant future, about 20 years ahead of us, which is the age after the Internet of Things. We're going from a network of people and things, smart objects, to a network of matter and energy. And let me give you some examples of this. So the Institute for the Future, we called it the age of networked matter. Why networked matter? Because through the internet and through our connection, we will be able to interact for the first time with how matter is composed, with the molecular state of things. Leonardo da Vinci, some years ago, already understood something. This is a famous sentence from Leonardo: learn to see. Realize that everything connects to everything else. Everything is connected. We seem to be apart from each other, but actually there is a physical thing in between us, which is air. It's not empty space, it's air. It's filled. And this air is connecting us. We're heading towards a time where atoms and bits are coming together. The difference in between what we create in a digital state, synthetic state, and biological things is going to be less and less. Even today, we're already making biological molecular computers. Quantum computing is out there. There are 2 quantum computers that are actually, we don't know how to use them. that's the problem, because it's so complex that we don't know how to harness all the potential of these new technologies. But yes, we're getting there. We're making biological computing. 3 examples of this, heading towards the conclusion. 5 more minutes. The Atlantic Rainforest Sensors Networking Project. With this very short name to define a very important project that has been done in the Amazon forest. So this project was initially started to monitor the state of the Amazon forest and to see how it's doing. You know, the Amazon forest is obviously very important for our planet. But while doing this, they discovered something else. They discovered that plants and the forest itself have patterns by which they actually relate to each other. They communicate. There is a language. We just don't understand it, but it's there. So today we know that there is a language, an encoded language by which living vegetables, plants communicate with each other. And how can we use this for ourselves? So they were putting sensors in cities to measure the quality of the air, for example. But the best sensors we have to measure the quality of the air are plants. In a leaf is all you need to really understand the composition of the air. And the problem is, how do I connect to it? How do I understand the language of plants? Okay, this is happening. We're beginning to know that there is this language and trying to decode it. Brain is another project where we're understanding how our brain is mapped, how information goes through our brain, our neuroconnection. We have something called neuroscience. You will hear very soon about new marketing, the capability to do marketing through brain waves. You know? Very dangerous stuff. But imagine if each one of these strings that you see, these connections, these flows of data that go through our brain can be connected directly to a machine. Then we can see how easily we can be able to connect ourselves, our brain, directly to machines. To finish off, this is Autodesk. I'm sure you know Autodesk. It's the producer of CAD, computer-aided design. Every object that goes into production today, or housing, any piece of hardware, is essentially designed through CAD, and because CAD is the software that then goes to CNC machines and to production. Now, in the labs of Autodesk, there is a project called Project Cyborg that is actually trying to develop, it's not there yet, but they get into it, the software that designers and builders of the future will need to create objects made with materials that change their molecular state. As you can see here, you have a molecular modeler, you have metabolic pathways you can design. So we are actually getting the ability to design at DNA level, at molecular level. Okay? And influence the state of materials. Something, you know, with the transparent may become opaque and so on. And to create really organisms, not just objects anymore. Objects in the future will be organic. They will integrate within our natural ecosystem. To recap, we've seen a lot of things today. These are the 3 ages of the internet we will go through. We've seen examples of technologies. I hope I didn't scare you too much, and this is it for today. Thank you.